Hello again, this is Mr. Andre. This is Chapter 1, Section 6, entitled Algebra, Functions. Pretty straightforward there. Basically, a function is a relation in which each element of the input is paired with blank elements of the output, according to a rule. Basically, paired with one element of the output. A function table organizes the inputs, blank, and output of a organizes the input value and output of a function. A function rule describes the relationship between each input and output of a function. All right, a function table. Basically, what a lot of people think about is you have a machine. Okay, a function machine. And just like any machine, it does something, it does something for us. You put some numbers in to the machine, and it does some work, and then it spits out whatever else, some new numbers. So basically, this work is your function rule. So complete the function table. The rule is x plus 6. So our machine here is doing x plus 6. What you're doing is you're saying you are adding 6 to each input. So last class, last video, you should have talked about here's x plus 6, and say that x equals 2. So you're putting 2 into the machine, and you're adding 6 to it. So here, 0 into the machine. Do some work on it. And you now know that x plus 6 is your rule. You're saying let x equal 0, plugging it in, and getting 6 as your... All right, let's keep going here. So like here we did 0 plus 6, and we got 8. Here it's 1 plus 6, and we got... Oh, I'm sorry, not 8. I got a little ahead of myself here. 0 plus 6 is not 8. 0 plus 6 is 6. 1 plus 6 is 7. And 2 plus 6 is 8. So this right here is where you're putting the input. All right, complete the function table. We know the rule is x plus 2. So we start with x plus 2. We take 0, we plug it in. And now we know our output. Start with x plus 2. Put 1 in there. And we now know our output. Oh man, I'm having trouble with my addition today. Hopefully you all saw the crazy mistake I just made. 0 plus 2 is not 0. 0 plus 2 is 2. Alright, so let's do it one more time. Let's make sure I don't make a mistake this time. X plus 2. Put a 2 in there. And hopefully everyone knows that 2 plus 2 is 4. I mean, I don't know that 0 plus 2 is 2. You know, I have to be reminded of it. But 2 plus 2 for sure is 4. All right. So you can actually have a little more complicated ones. So our input is x. Our output is 2x plus 1. And you can just choose some random values and plug them in. So we've got 2 times 1 plus 1. I plugged 1 in for x. That's 2 plus 1, or 3. 2 times 2 plus 1. That's 4 plus 1. 2 times 3 plus 1. That's 6 plus 1. So you can see now that it is increasing by 2 each time. That is your pattern. So let's talk about patterns here. Finding the rule for a function table. The outputs here are how many less each time? It's 2 less. The output is, oh, I'm sorry. The output is blank less than the input. So it's 3 less than the input each time. Between here, that's 3. Between here, that's 3. Between there, that's 3. So what that tells us is you're going to take the x value. So the rule is you start with x. And how much less is it? Minus 3. So now I could say that what if x was 20? You could say, all right, 20 minus 3, 17. And then in our table, 20 would meet with 17. All right, here's another rule. What's the difference between 9 and 36? Well, let's check this out. 9 to 36. So 27. The difference between 10 and 40. 30. Difference between 11 and 44. 33. So back here at this example, notice that it went up. Here's the difference. The difference for this one was 2, and then 3, and then 4. So when the difference is the same, it's a piece of cake. It's just x minus that number. But now there's a little something extra here. So we have to come up with how to increase this. All right. Remember, over our definition, one of our definitions talked about, oh, it must have been from last class, talked about operations, a rule with an operation. Here, nothing works for us in 27, 30, and 40 as the differences. But you can multiply by 4, multiply by 4, multiply by 4. So when you multiply by 4, you now are taking the x value and multiplying by 4. So my equation, my expression, is just 4x. All right. When you choose a variable to represent the input, it is called defining the variable. So that's what we're doing right here, defining the variable. Nina has a new job. She spends $2 every day on coffee. Define the variable. Let x represent the number of days. Then write a function rule that relates the total amount of money Nina spends on coffee, the number of days worked. So the equation, $2 for each day represents the number. Now if we did this, if we said that it represents the number of days, 1 day would be $2, 2 days would be $4, 3 days would be $6. Okay? So we're taking each of these numbers and multiplying by 2. So here, 2 times x is my equation. That's because you're multiplying each of the x's to work. All right, a video store rents movies for $4. Define a variable. Then write a function rule that relates the total charges to the number of movies rented. So there you go. The variable, let's make it m, equals number of movies. Then write a function rule that relates the total charges to the number of movies rented. So, one movie would be $4. Two movies would be $8. Three movies would be $12. Four movies would be $16. And what you'll see eventually is that you're multiplying each of these x values by 4. Therefore, my equation, or my expression, is 4m. 4 times the number of movies bought. All right, so take a look at these problems in your book. Make sure you do the CYUs. Check your understandings, and we'll get back to you.